In this, I'm just going to kind of take a problem through using the first and second derivative, not with a graph, but how we could analyze it by using the derivative and second derivative. So the function is x cubed minus 6x squared minus 2. Let me put all my work down here, and we'll then go back and fill in the answers. First thing it asks for is critical points. Critical points occur when the derivative is 0. So there's the derivative, 3x squared minus 12x. Let me do a little factoring here. I could pull a 3x out, and I'd be left with x minus 4. So what makes that 0 are 0 and 4. So those are our critical points. The function is increasing when the derivative is positive. So now we got to do a little sign analysis on our derivative. So let me put in the zeros. If I plug in a number less than 0, so pick a negative number, I get negative times negative. Well, that's positive. If I plug in a number between 0 and 4, let's say like 1, I get a positive and a negative. That's negative. If I pick a number bigger than 4, I get a positive and a positive. It's positive. Well, again, we're increasing when the derivative is positive, so we're talking from negative infinity to 0 and from 4 to infinity. Okay. Next, inflection points. Well, that occurs when the second derivative changes signs. Okay, now I'm going to talk about that again in a second, but let me find the second derivative here. We get 6x minus 12. So I'm going to do a little sign analysis on my second derivative right here. What makes that 0 is 2. It is not enough right now to just say the inflection point is at x equals 2. We actually need to verify that there is a sign change, that it changes from positive to negative or negative to positive. It is not enough to say that the second derivative is 0 there. There must be a change in signs. Okay, so just remember that. That is one of the most commonly missed questions on the AB exam. All right, if I plug in a number less than 2, I get a negative. If I plug in a number bigger than 2, I get a positive. So you'll see that there actually is a sign change there. So x equals 2 is an inflection point. Now, concave up is where the second derivative is positive, 2 to infinity. And finally, on the interval, find the maximum and minimum values of the function. Well, this comes down to a candidate test. You know, if you've forgotten that, I'm just going to make a little note here of candidate test. What candidate test says is if you check the endpoints, okay, in the original function, so I'm just going to do this work right down here. We're going to plug in negative 1 and 4 to my original function, and we plug in the critical points, and you'll notice one of them is 4. So really, you know, on our interval, this is the end. We're not including any of this stuff over here, but we should plug in critical points, endpoints, and into our original function, and just see which gives the larger and the largest and smallest values. So if we do that, you know, and I'll just tell you real quick what those come out to be. If you plug in negative 1, you get negative 9. You plug in 0, you get negative 2. If you plug in 4, you get negative 34. So the maximum value is negative 2. Make sure you don't say it's 0. It's not. It's at x equals 0, but the maximum value of the function is negative 2. Of course, negative 34 is the minimum value. All right, so remember your candidate test. If you have endpoints and you're asked for the minimum and maximum, the best way to do it is plug in the critical points and the endpoints to your function and see what the biggest and smallest values are.